In this video, I'm going to give you an introduction into the types of chemical reactions. In a chemical reaction, you have compounds or molecules. As they collide into each other, the bonds of the atoms of each compound or molecule are going to break, and those atoms are going to be allowed to rearrange. And then those rules of electron transfer and atom ratios that we see in chemical bonding are all going to naturally happen as this reaction is occurring. So what you're going to have is those atoms are going to rearrange, form new compounds or molecules. We call those new products. Products, and the reactants are what's reacting to form the products. When I was a kid, my grandmother had this camera that had this stack of flash bulbs, and each little bulb had a one-time use, and the filament in those little bulbs were made of magnesium. And when she took a picture, there was a one-time flash, and it was a one-time use for that little bulb. What's happening inside, it would get coated with this white powder called magnesium oxide. I'm going to demonstrate that to you right here. So we have magnesium. I'm going to supply some energy, and this energy is going to be used to allow the oxygen in the air to react with magnesium. And once that reaction starts, there's enough energy for it to keep going. You can see that bright white light there. That models that white flash I would see in the flash bulb. So what's happening right here? Well, the energy is being used to separate the atoms of oxygen in the gas or the molecule of oxygen. And once those oxygen atoms have been freed, they're allowed to react with magnesium to form this white powder called magnesium oxide. In a chemical reaction, the products are going to have properties that are completely different than what we started with. This white powder does not have the same chemical properties as magnesium that started the reaction. This is actually a type of what we call synthesis reactions. There's different ways to categorize reactions. We can talk about, we can look at how electrons are being transferred between reactants and products. We call those oxidation reduction reactions. But here I'm going to just look at how atoms are rearranging to form new products. And we're going to go through those four types of examples. First one being synthesis. If you look here on the board, synthesis, here's my basic equation. I have reactant A reacting with reactant B, giving me one product called AB. Examples of this would be sulfur reacting with oxygen, giving me sulfur dioxide. Or like I showed you, magnesium plus oxygen giving us magnesium oxide. In this example, I have H2 plus O2 giving us water. Notice in synthesis type reactions, we end up with one product. But if you notice in this second one, I'm only ending up with one oxygen atom when I started with two. Now that's not what happens in reality, so I have to represent the reality. And how do I do that? By what we call balancing chemical equations. And so I need to add some what's called coefficients in front of the reactants and products. So I basically end up with everything I started with. You can look at a chemical reaction of before and after. So if I start with two atoms of oxygen, I have to end up with at least with exactly the same number of oxygen atoms that I started with. So I add a coefficient. We do not add subscripts because that would change this. If I added a subscript of 2 right there, I no longer have water. I have hydrogen peroxide. So I'm not changing the subscripts of the chemical formulas. I'm changing or adding or modifying the coefficients. Well, all of a sudden now, that tells me I ended up with a ratio or a number of hydrogens of 4, which means that's what I had to have started with as well. And of course, just one oxygen. So for this reaction to occur, here's the ratios of reactants to products. So I actually need 2 hydrogen molecules to react with 1 molecule of oxygen to end up with 2 molecules of water. So I'm just simply representing the law of conservation of matter, which just simply states that I'm not going to create, I'm not going to destroy atoms. I'm going to end up with everything I started with. That's what happens in nature and reactions. I just need to represent that when I write these chemical equations. The opposite of this is what we call decomposition, where I start with one reactant, but I end up with 2 or more products. just the opposite of synthesis. So here you can see I'm starting with reactant AB, and it's breaking down into two products here, A plus B. My example here, calcium carbonate breaks down into calcium oxide and carbon dioxide. My second example, we're starting with potassium chlorate, breaking down into potassium chloride and oxygen gas. So I'm going to balance this second chemical equation here. So notice I'm starting with 3 oxygens and ending up with 2. Least common denominator would be 6. So I'm going to add a coefficient of 3, not changing the subscripts. That gives me 6 atoms of oxygen. I come back here and I add a coefficient of 2. That gives me 6 atoms of oxygen. But now I've just changed the KCl's. So I got to add a coefficient over here to show that I ended up with everything that I started with in its most simplest ratios. So those are the first 2 chemical reactions. At this time, we're going to transition and show you the other 2 types of chemical reactions. The third type of chemical reaction we're going to discuss is what's called single replacement reactions. So if you look at my bare example here, I have A plus compound BC equals AC plus B. Again, chemical reactions here. Here's before, here's after. What's actually happening here is A is replacing B to bond with C. And so now B will be off by itself. So let's look at some examples here. I have zinc reacting with HCl, giving us hydrogen gas, plus zinc chloride. If you look at what's happening, zinc is a metal. It has a tendency of transferring electrons to nonmetals. And hydrogen, even though it's a nonmetal, is almost losing its electron with chlorine. It's still sharing electrons. This would be a polar covalent compound. But who's zinc most likely going to replace? The hydrogen. They're both acting as those giving away electrons, chlorine's taking. So in this reaction, zinc is going to replace hydrogen, end up with chloride, or chlorine, and that's how we get zinc chloride. This equation also needs to be balanced. Notice I'm ending up with 2 atoms of chlorine, which means I had to have started with 2 atoms of chlorine. Now when you add a coefficient, that doesn't just change the chlorine, that also changes the number of hydrogens you have. So whenever you add a coefficient, that's going to influence the number of atoms of everything in that compound. What works out nicely here is I have 2 hydrogens, I end up with 2 hydrogens. Here's another example. Sodium's reacting with water to give us sodium hydroxide and hydrogen gas. So what's happening here, sodium again has a ion charge of 1 positive. It's giving away 1 valence electron, which is just like hydrogen. So you're going to see sodium replace the hydrogen, and we end up with sodium hydroxide. All right, notice though, I ended up with 3 hydrogens when I only started with 2. Well, if I just add a 2 coefficient here in front of sodium hydroxide, that now gives me 4 hydrogens, 2 oxygens, 2 sodiums. So I come back to my reactant side. If I started with 2 oxygens, or excuse me, if I ended up with 2 oxygens, I had to start with 2 oxygens. That gives me my 4 hydrogens, but I can't forget about the sodiums. So I got to add a coefficient of 2 in front of Na here as well. So I have 2 sodiums, 2 molecules of water. It's going to give me 2 compounds of sodium hydroxide and 1 molecule of hydrogen gas. So we call that a single replacement reaction. If I have 2 compounds, that's what we call a double replacement reaction. So notice here I have compound AB reacting with compound CD to give us 2 new compounds. Well, what's happening here? The A is going to replace the C. They trade places. That's why we call it a double replacement. So here's hydrochloric acid, sodium hydroxide. What's happening? The hydrogen and the sodium are going to switch places. I'm going to end up with sodium chloride, which is salt and water. Look at this other example. Calcium carbonate, hydrochloric acid. I end up with calcium chloride and carbonic acid, which carbonic acid is going to undergo another decomposition reaction to give us water and CO2. But we can leave it as H2CO3 just as it is right there. So I need to balance this chemical equation. Well, if I have 2 hydrogens here, I had to have started with 2. That also changes the number of chlorines I have, which gives me 2 chlorines here. But let's double check everything else. I have 1 CO3 here, 1 CO3 here, I have 1 calcium here, 1 calcium here. So that chemical equation looks to be balanced as well. So in summary, chemical reactions, what's happening? The reactants are colliding, and if there's enough energy in those collisions, the atoms of each reactant are going to separate from each other, and reactants are going to, or excuse me, the atoms of those compounds, of the reactants, are going to rearrange to form new products. All chemical reactions require some energy to get started. We call that activation energy. And when I write out chemical equations, I need to balance by adding, changing coefficients to clearly show the law of conservation of matter. And we can easily categorize our chemical reactions into these 4 categories. There's others. We didn't talk about combustion. You can take any, like a hydrocarbon, like if you use your gas grill, you have propane gas that's going to react with oxygen to give us carbon dioxide and water. That's another category of a chemical reaction called combustion. I can easily fit it into one of these categories as well. That gives you an introduction and just a summary of the types of chemical reactions and just what's happening in chemical reactions.